Charles Keeling, cornerstone of climate science. In 1958, Charles Keeling discovered that carbon dioxide levels were increasing while studying the Mauna Loa volcano in Hawaii. By collecting this data and presenting it to the world, Keeling provided evidence that climate change existed, was going to continue to get worse, and will have very bad consequences, opening a new frontier in climate science that could one day save the planet. Through Keeling collecting his data and presenting it to the world, the talk about climate change became a hot topic and lots of attention was drawn to it. Charles David Keeling eventually became a scientist who was the first to confirm the rising concentration levels of carbon dioxide and connected it to the rising temperatures of the Earth. But before he started taking steps to save the planet, Charles Keeling was born to Ralph Franklin and Grace L. Keeling in Scranton, Pennsylvania on April 20th, 1928. In 1945, he graduated from Liberty Township High School and went on to go to the University of Illinois. Keeling graduated from the University of Illinois 3 years later, graduating with a degree in chemistry. Later on, in 1954, he earned his PhD in chemistry from Northwestern University, which is a private university in Illinois. After earning his degrees, he moved on to work at Caltech, also known as the California Institute of Technology. At this private nonprofit university, Keeling devised an instrument called the manometer, a device used to measure carbon dioxide. The manometer is a very sensitive instrument, enabling it to accurately measure carbon dioxide. In 1956, Keeling joined the staff at the Scripps Institute of Oceanography in San Diego, where he conducted research for the next 40-plus years. During his time with Scripps, Keeling continued his carbon dioxide research at the Mauna Loa volcano in Hawaii. A station was built 2 miles up the dormant volcano. Keeling brought his manometer with him to help his work on the Mauna Loa volcano. The research station was situated at this location because it was far from pollution, being high up on the largest volcano in the world and hundreds of miles away from the mainland. It's on an island, on a mountain, in the middle of the ocean, Keeling said. It's like a probe sticking into this remote part of the atmosphere, so the air that it sees is really characteristic of a large chunk of the world. His first measurement of carbon dioxide at Mauna Loa was 315 ppm, also known as parts per million, and milligrams per liter. Keeling continued to test the air using his manometer pretty regularly. Each year, he noticed that there was an increase in carbon dioxide by 1 part per million. He also noticed through his investigations that each month there was a slight increase as well. The carbon dioxide was also found to fluctuate throughout the seasons, but overall there was a continuous increase. He made a graph of this to show the trends. It was titled the Keeling curve, named after him. CO2 stays in the air for a very long time, said Keeling. It doesn't wash away or anything like that. The scientist explained that it will be very hard for people to scrub the CO2 from the air and return the climate back to normal. Keeling acknowledged the fact that climate change wasn't entirely reversible, but he said that we have to start somewhere. The most notable thing about Keeling's graph is what it's telling us. Through the use of his graph, it makes the carbon dioxide rise undeniable. Although it was 313 parts per million back in 1958, as of today, it has risen over 100 parts per million and sits at 420 parts per million. Climate scientists like Charles's son Ralph think that the levels of carbon dioxide are likely to hit 450 parts per million in the next decade. Keeling presented his research by publishing nearly 100 articles on atmospheric chemistry and the carbon cycle. Before Keeling's research, scientists believed that oceans would absorb any excess carbon dioxide caused by the burning of fossil fuels. Keeling's groundbreaking research proved that this was not the case, and that not only was excess CO2 not absorbed by the oceans, but also that it increases the concentration of carbon dioxide was directly correlated to increases in fossil fuel emissions. Keeling's work helped reveal the existence of the greenhouse effect and global warming. Keeling's studies prove that the rise in carbon dioxide levels is the effect of the increase of fossil fuels being used in the world. The light on his theory was shed early into his research, with other scientists relating his discoveries to global warming. Keeling has also warned the public that this will have really bad consequences. Some of these he included were stronger floods, fires, and droughts. Also, as the ice caps melt due to higher temperatures, the sea level is rising. Some of this is already happening, explained Keeling, referring to the effects of climate change, and it will only get worse. Through his analyzations of carbon dioxide in the samples he took, Keeling was able to accredit this rise of carbon dioxide to the use of fossil fuels. Keeling discovering climate change and presenting it to the world created a new frontier to climate science research and knowledge. Many other scientists have continued Keeling's research and added on to his discoveries. The Keeling curve can be used as a link between carbon dioxide concentrations of current times and those of the past. A team of researchers with members from Princeton University, the University of Maine, and Oregon State University noticed that the data in the Keeling curve can be compared to the carbon dioxide concentrations from air bubbles found inside ice cores. These comparisons highlight that for the duration of 1000 and 2000 CE, the concentrations of carbon dioxide fluctuate from around 275 parts per million and 290 parts per million. However, these levels have reached 416 parts per million by 2021, meaning that they have risen significantly since around 1900. Many other studies have shown that there is a close association between near-surface temperatures and atmospheric carbon dioxide concentrations. The ice core studies also help reveal that the timeline of the ice ages and warm periods through the fluctuation of atmospheric carbon dioxide. A main cause of the carbon dioxide levels rising was the increased amount of fossil fuels being used by humans. Humans did this through industrial factories and through the use of cars and other automobiles. The Keeling curve is still used today to help scientists research climate change. Many scientists have also continued to collect data since Keeling's passing in 2005. On June 12, 2002, Charles Keeling was awarded with the President's Medal of Science from President George W. Bush in a White House East Room ceremony. During the ceremony, Bush presented Keeling with the award, praising him for his pioneering and fundamental research on atmospheric and oceanic carbon dioxide, the basis for understanding global carbon cycle and global warming. Tragically, on June 20, 2005, Charles David Keeling passed away due to a heart attack in his summer home in Hamilton, Montana. The legacy of Charles Keeling includes an ongoing measurement program to this day, and sharing a reliable record of carbon dioxide concentrations, which is the beginning of modern climate science. Many lectures, podcasts, news articles, and documentaries have been put in place because of Keeling's research, teaching more and more people about how climate change was brought to the public eye. The Keeling curve is the name given to the graph of his data. It is a very profound symbol of the impact humans have had on the environment and the impact fossil fuels have made on climate change globally. To this day, Keeling's son Ralph continues his work as a climate scientist. He studies the carbon dioxide levels around the world as well. "We're breaking records every year," Ralph Keeling said to Newsomatic. So this is another record. By expanding into this new frontier, Keeling brought climate change to the world's attention and warned everyone of the consequences. Charles was one of the first people to study climate science, and is often referred to as the cornerstone of climate science.